Okay, so we are going to start with our review topics today. We're going to start by talking about linear functions. So again, linear functions we talked about in the fall, but you had some experience with linear functions before you even got to Algebra 1. You did some of this in 7th or 8th grade. So remember, when we talk about linear functions, if we're looking at a graph, we're talking about a graph of a straight line, right? I should be able to take a ruler or the edge of my notebook or my folder or my calculator case, whatever, and line it up, right? And not have my graph shift off of that straight edge, right? That's the idea behind a line. It doesn't curve at any point, okay? This line has a positive slope, but I could also be talking about a line that has a negative slope. And we'll talk a little bit more about that in a little bit. When I'm looking at a table of values, what I'll see is that when I have the same change in my x values, and it doesn't matter what that change is, here it's 1, but it could be every 5 for my x. When I've got the same change for my x's, I see the same change in my y's as well. So for my y values here, we're adding 1 each time. I could be adding 7 each time, or I could be subtracting 2 each time, but I'm always either adding or subtracting the same amount. So for that change in our y, we always add or subtract the same amount. That tells me I've got a linear function. Now, when we talked about linear functions in the fall, we did talk about 3 forms for a linear function. The one I'm not including here is standard form. I want to focus on things that you're going to encounter in Algebra 2. And in Algebra 2, you will rarely, if ever, see a standard form linear equation. However, you will see slope-intercept and you might see point slope. So we're going to focus just on those 2. So for slope-intercept, it's called that because I see the slope and the y-intercept. For both of these functions, m is our slope. So whatever value I have in for m is the slope of my line. And then for slope-intercept, that b value is our y-intercept. For point slope, the x1 and y1 that I see here are parts of a point that is on the line. So the x value here and the y value here come from an ordered pair that is a point from the line. When I talk about linear functions in context or applications of linear functions, I'm always looking at something that kind of hits the big themes we see in that example there. So this is a rideshare company, charges a $5 reservation fee and then 20 cents per mile. So we're always going to see something like we have this maybe starting charge or flat fee or something like that, plus in this case, an amount per mile, or maybe an amount per box, or an amount per gallon, something like that. And the context will change. It won't always be money, but we'll often see some sort of kind of starting point and then a constant change per item. Okay, and that change per item will be the same every time. That's what will differentiate us from our exponential function. So this is sort of an overview of everything that we're going to see with linear functions. Today, we're going to start by talking about graphing from slope-intercept form. Tomorrow, we'll talk about graphing from point-slope form. We'll also talk about being able to represent applications with a linear function, and we'll talk about being able to draw connections between a graph or a table and the maybe context I have for a function. So we're going to see all of that. Again, we're just going to kind of parse it out a little bit. So to start, we're going to talk about graphing from slope-intercept form. So I know we just talked about this, but slope-intercept form for a linear equation tells us the slope and the y-intercept. Remember, the y-intercept is where our graph crosses the y-axis. So those 2 pieces of information are what we get from slope-intercept form. it looks like this: y equals mx plus b. I know we just saw it in that table above. And remember, m is the slope of our line, and b is our y-intercept. They were not trying to be tricky when they named it. Slope-intercept form, slope, y-intercept. As we're graphing today, remember that when we talk about slope, as we're plotting points, we're going to talk about slope as a rise over run. Now, our rise could be up or down, depending on if our slope is positive or negative. When we talk about run, we're always talking about moving forward. So rise could be up or down, but as I start plotting points, I'm always running forward. So let's take a look at a few of these. So for A, we're going to graph this linear function here. I want to start by identifying the y-intercept. I need to start with a point on the graph. Okay? So my y-intercept here is at the end. I've got 2x minus 1, so my y-intercept is negative 1. So I'm going to go down to where y is negative 1, and I'm going to plot my point there. And then my slope here is 2, right? That's my m value. Now, I just said we think about slope as rise over run, but this doesn't look like a fraction. It just looks like a whole number. So anytime my slope is a whole number, I'm going to think about it as that number over 1. So I can see both the rise and the run. Now, since this is positive, that tells me I'm going to go up. So from my y-intercept, I'm going up 2, I'm rising 2, and forward 1. I'm going to run 1. And then I keep following the same set of directions to get more points on my line. So from my new point now, up 2, forward 1, up 2, forward 1. And I want you to fill your coordinate plane here till you run out of space, so you can't plot any more points. Okay? Once we've gone as far as we can to the right, we want to put some points on the left half of our graph. To get points back on the left side of our graph, we're going to completely reverse those slope directions. So we were going up 2 and forward 1. To get points to the left, I'm going to go back to my y-intercept and go down 2 and backwards 1. So I'm doing exactly the opposite of what we did before. And again, fill your coordinate plane. Because we're plotting points on a line, I should be able to take my ruler or my notebook edge or my calculator case or my whatever I've got that has a straight edge to it and line it up with all of those points. Okay, if you get a point that doesn't fall on that line, that's your hint that something's wrong. Or if you have like a little like jog in your graph, like you're over here now, and these form a straight line and these points form a straight line, but there's a disconnect, go back and double check your slope as you were plotting, okay? You should be able to line them all up. They should make a straight line, okay? Because it's the graph of the line. Once you've plotted all your points, connect them, throw your arrows on the end. Familiar? Yeah, it should be. For B, we've got a y-intercept at +3. So I'm going to start by plotting my y-intercept at +3. And then my slope this time is a half. So I'm going to rise a 1, run forward 2, 1 over 2. Okay, up 1 over 2, up 1 over 2, up 1 over 2. And again, fill your coordinate plane till you run out of space. When I run out of space moving forwards, we'll reverse our direction to move backwards. So down 1, back 2, down 1, back 2, down 1, back 2. And again, I want you to fill your coordinate plane. Everything should line up. Once you've got your points plotted, connect them, throw your arrows on the end. We've got a few more examples graphing from slope-intercept form that we're going to take a look at on the next page. So if you would for me, please go ahead and turn the page. And again, remember we start by plotting our y-intercept. So for example C, our y-intercept is at 4. So I'm going to go to 1, 2, 3, 4, plot my point. And then my slope is -3. So I'm going to write this as over 1 so I can see both the rise and the run. Since my slope is negative this time, we're going down with our rise. We always run forward. So from my y-intercept, I'm going to go down 1, 2, 3, and forward 1. Down 1, 2, 3, forward 1. Down 1, 2, 3, forward 1. And again, we just keep going until I run out of space. Now I'm going to reverse those directions to get some points to the left. So up 3 and back 1. Up 3 and back 1. Once you have filled your coordinate plane, connect your points and throw your arrows on the end. Questions for me so far? Okay. For D, I would like to start by plotting my y-intercepts, but I do not see a B value at the end. So if I don't see anything at the end of my function here after the x, what does that mean for my y-intercept? It's at 0, yeah. This is like saying we've got +0 at the end. So I'm going to go ahead and plot my y-intercept. It's right on the origin this time. And my slope is -1/2. So I'm going to go down 1, forward 2. Down 1, forward 2. Down 1, forward 2. And then reverse those directions, moving from the y-intercept backwards. Don't forget, when you've plotted all your points, connect them, throw your arrows on the end. Oop, mine got a little wild here. There we go. For E, this time I don't see the number in front of X representing my slope. What's my slope if I don't see a number there? 1. So this would be 1. Since 1's a whole number, I'm going to write it as over 1 so I can see the rise and the run. My y-intercept here is 2. So I'm going to plot that up at 2. And then up 1, forward 1, up 1, forward 1. We got a lot of points out of this one. Reverse those directions, down 1, back 1 to get points to the left. Connect your points, throw your arrows on the end. For F, again, I don't see that B value at the end. That means that my y-intercept is 0. I'm going to go ahead and plot that. And then my slope is -2. So I'm going to write this as over 1. So again, I can see both the rise and the run. So down 2, forward 1, down 2, forward 1, down 2, forward 1. Reverse my directions to get points to the left, up 2, back 1. And again, I want you to fill your coordinate plane. Once you've plotted all the points that you can, connect them, throw your arrows on the end. Questions for me on any of our graphs? So we just graphed 6 linear functions in slope-intercept form. Which of them had a positive slope? So which of those parts of number 1 had a positive slope? A, B, and E all had a positive slope. So then which of them had negative slopes? C, D, and F, right? So when we talk about positive versus negative slopes, remember we read a graph from left to right, just like we read words on a page, okay? So as I read this graph from left to right, okay, as I read E from left to right, we would be going up, right? As I follow this graph from left to right, I'm going up. That's a positive slope. That's what we mean by positive slope. For F, as I read this graph from left to right, I'm going down. Okay, that's what we mean by negative slope. So positive means we're going up, negative means I'm going down. Again, we read a graph from left to right, just like words on a page. The last thing we're going to take a look at today is writing functions for graphs, again, in slope-intercept form. We're all about slope-intercept form for today. So on page 3, we're going to take a look at a few more examples. This time, we have the graphs of our functions. We want to write the equations for them. I'm going to start by identifying the y-intercept for each of these. So for A, my y-intercept, that spot where I cross the y-axis, is right here up at 5. So this is going to be y equals something x plus 5, since we're at positive 5 here. The next thing I'm going to do is identify the slope. Now we'll take a look at some slope formula problems a little bit later on as we work through this review material. But since we've got graphs today, I want to find the slope from the graph. So we're just going to count on the graph. That means I need to find another nice point on the graph. So the y-intercept is a nice point here. This guy's close, but not quite. Here's another one that's close, but not quite. My x-intercept lands at a nice point, so I'll use that one as my other nice point. So as I count, again, we're reading our graph from left to right. So I'm going to go from the leftmost point to the right point, right? Leftmost point forward. I have to go down 1, 2, 3, 4, 5. Since I'm going down, that's going to be negative 5. And then I move forward 1, 2, 3, 4. So my slope would be negative 5 over 4. Don't forget your x plus 5. You do not, and I do not want you to change your slope. You do not need to change your slope to a decimal. You do not need to change your slope to a mixed number. Leave it as a fraction. The only thing I ask is that you make sure you reduce. So if you got a slope to be something like 2 over 10, reduce that to 1/5. But don't change it to a decimal. We like slope to be as a fraction so we can see the rise and the run there. For B, I'm going to start the same way. Start by identifying your y-intercept. Our y-intercept this time is at 0, right at the origin. So I'm going to go ahead and put the plus 0 at the end here. But as we saw in a couple of our earlier examples, if your y-intercept is 0, you don't have to write it. I'm going to because I like to see it there to remind myself I found it already. And then I need to find another nice point on this graph so that I can count the slope. I've got 2 options for nice points on this graph. I've got this guy back here or this guy up here. It doesn't matter which 2 points you count between as long as you're going from left to right. Okay? So I'm going to go ahead and go from our y-intercept to the next point forward. So this would be up 1. And then over 1, 2, 3, 4, 5. So 1 over 5 is our slope. Don't forget your x. So y equals 1/5 x or 1/5 x plus 0. Questions for me so far? Okay. For C, again, I'm going to start by identifying my y-intercept. So my y-intercept is right here. That's where I cross the y-axis. That's at 1, 2, 3, 4. So y equals something x plus 4. To find my slope, I need to find another nice point on this graph. I've got a couple spots that are close, but not quite at that corner. If I come all the way down here, I've got a point that crosses right at a corner on my grid. So I'll use that point. So to go from left to right, I have to go 1, 2, 3, 4, 5, 6, 7, 8 up. And then 1, 2, 3 forward. So I have y equals 8 over 3x plus 4. Again, don't change it to a decimal. Don't change it to a mixed number. Just leave it as a fraction. Reduce if you need to, but leave it as a fraction. Because we're going up, we always go from left to right. So my leftmost point is here. And then finally for D, again, start at our y-intercept, which is positive 2 here. So y equals something x plus 2. I've got, again, 2 options for other points on my graph. It does not matter which 2 you count between, but make sure you're going left to right. So I'm going to start at my y-intercept and count to the next point forward. That would have me go down 2, so negative 2, and then over 1, 2, 3. So negative 2/3 x plus 2. Don't forget to put the x in your function. For number 3, which of our graphs had a positive slope? B and C. And which of our graphs had a negative slope? A and B. Not too bad? Okay. Again, this is all going to be review. It's all stuff that we've talked about before. Some of it we haven't seen in quite a while. We haven't graphed a line in quite some time. So we're going to, again, cover each one of these review topics as we move forward. Next time, we're going to talk about graphing and then writing functions from a graph in a point slope form.